Right now, somewhere above you, maybe just a few thousand feet overhead, something extraordinary is quietly happening. Invisible water is becoming visible. Air is transforming into shape. And the sky is painting itself, one tiny droplet at a time. Tonight we're going to float up there together and let the science of clouds carry you gently, all the way, to sleep. And if the slow wonder of science helps you rest, don't forget to subscribe to Sleepy Science, so a new peaceful journey is always waiting for you. Let's begin with the most comforting truth about clouds. A cloud is not made of cotton, it's not made of smoke, it's not even made of mist the way we imagine it. When we were children, we looked up and saw something soft and solid, something that looked like it could hold the weight of a person, like a place you could curl up and rest. Something that looked more than anything else, like the world had placed enormous pillows in the sky just for the pleasure of looking at them. And that image stays with us. It follows us into adulthood. Even now, when you look up on a slow afternoon and see a wide, rounded cloud drifting peacefully overhead, some quiet part of you still thinks, just for a moment, that it looks like something you could sink into. Something that would hold you, something soft and thick and real. But the truth about clouds is even more beautiful than that, and somehow, even more restful. A cloud is made of water, not water the way we pour it into a glass, not water the way it sits in a still lake reflecting the trees on the far shore, not water the way it falls in rain or gathers in the hollow of a leaf on a cool morning. It is water in its smallest, quietest, most delicate form. A cloud is made of millions upon millions of microscopic water droplets, each one almost unimaginably tiny, each one so small and so light that the simple, slow upward movement of warm air is more than enough to keep it floating. Not with effort, not straining against gravity, but resting in the air the way a thought rests in the mind, present, weightless, barely there. To understand just how small these droplets are, consider this. A single human hair, something we think of as thin, as fine, as nearly nothing, is still roughly 100 times wider than a single cloud droplet. 100 times. That means if you were to line up 100 of these tiny water droplets side by side, the row they form together would still only be as wide as one strand of your hair. They are not small the way a grain of sand is small, or the way a dust mote floating in a shaft of afternoon light is small. They are small in a way that sits at the very edge of what we can picture. Small enough that the word small almost stops meaning anything at all, and yet they are real. Each droplet is a perfect spherical bead of liquid water. Round the way, all liquids are round when surface tension pulls them into themselves, when water tries to take up as little surface area as possible and curls gently inward. Each one a tiny silent globe of water sitting in the air held up by the faintest movement of atmosphere. They do not fall, they do not rush, they simply exist, hovering, patient. Each one a small miracle of physics that asks for almost nothing in return for the wonder it creates, and there are so many of them. A single cloud, the kind you might notice drifting over a field on a warm afternoon, the kind that doesn't seem particularly impressive, not a storm cloud, not a towering formation, just a modest, pleasant, everyday cloud, contains around 100 water droplets in every single cubic centimeter. Now picture how large that cloud is in the sky. Picture the shape of it, the slow curve of its edges, the way it stretches across a section of blue. That cloud, from edge to edge, might occupy hundreds of millions of cubic centimeters of sky, and in every one of those cubic centimeters, 100 tiny droplets are quietly suspended. The total number of droplets in even a small cloud runs into the hundreds of billions of individual beads of water, each one too small to see, together creating something large enough to cast a shadow over a whole town. It is, if you sit with it for a moment, one of the most quietly astonishing things in the world. There is something deeply peaceful about the way clouds hold together. They do not have a skin. They have no boundary the way a ball has a surface. If you flew through the edge of a cloud, and people do every time an airplane descends through overcast sky. You would not feel yourself pass through anything solid. You would simply notice gradually that the air around you had become wetter, that visibility had softened, that the world outside the window had turned to white. The edge of a cloud is a gradient, not a wall. It is a place where the air slowly becomes cloudier and cloudier until somewhere in the middle, you are surrounded entirely by floating droplets and cannot see more than a few feet in any direction. The cloud does not know where it begins. It fades in and out of existence at its edges, like a thought that arrives gradually, like sleep itself coming on slowly at the end of a long, quiet day. And the shape of a cloud, that beautiful, rounded, sculptural shape we love so much, that is not fixed either. A cloud breathes, it shifts. Its edges dissolve and reform constantly as droplets evaporate at the surface and new droplets condense a little further in. The cloud we see in the sky is not the same cloud it was 10 minutes ago. New water is always joining it. Old water is always leaving. Like a river, it appears still from a distance but is always moving. The shape persists even as the substance changes. The cloud continues even as each individual droplet comes and goes. There is something deeply comforting about that, something that feels almost like a lesson, that a thing can remain itself even as it constantly changes. That stillness and change are not opposites, that they can exist together, gently, in the same drifting form. A cloud is really just water, wearing air like a coat. It has taken on something invisible and made it visible. It has turned the atmosphere, something we move through every moment of our lives without noticing, into something we can see and watch and feel a kind of quiet affection for. The air has always been there, full and present, pressing softly against our skin. But the cloud makes a part of it show itself. It draws a shape in the sky and says, "Here, look here." Something is happening here, slowly and peacefully, and it has been happening long before today, and it will keep happening long after. What is especially wonderful is that clouds are not rare. They are not reserved for special places or special seasons. They are almost always present somewhere above us, even when the sky appears perfectly clear and blue. On a cloudless day, water vapor is still rising, still drifting, still reaching for altitude. It simply hasn't yet cooled enough, hasn't yet found the right conditions to condense into droplets we can see. The cloud is there in potential, waiting. The sky is always on the verge of making one. And then, as the air cools slightly, as the invisible particles of dust and sea salt do their quiet work, the water finds its way. And what was invisible becomes visible. What was nothing we could point to becomes something we stop and look at. People have always looked at clouds. Long before anyone understood the physics of condensation or the thermodynamics of rising air, people looked up and felt something. Calm, often. Wonder sometimes. A kind of spaciousness in the chest, as if the sight of something slow and enormous, and unconcerned with human affairs was itself a form of rest. There are written records going back thousands of years of people pausing in their work to look at the sky, of travelers describing the clouds above unfamiliar landscapes, of poets reaching for words to hold the particular quality of light falling through a cloud on a late afternoon in autumn. Every culture that has ever existed has looked up, and the clouds have always been there to look back, or not to look back, which is almost better. The clouds do not need us. They were drifting before we arrived. They will drift after we are gone. There is something in that fact that makes the body soften and the breath slow down. In the 19th century, a man named Luke Howard sat down and gave clouds their names. Before Howard, clouds were simply clouds, beautiful and changeable, and beyond categorizing. Howard was an amateur meteorologist, a quiet and careful observer, and he felt that clouds deserved to be known more precisely. He looked at the sky for years, watching the different forms that water took in the air, and he began to sort them. He gave them Latin names: cumulus, meaning heap; stratus, meaning layer; cirrus, meaning curl of hair. These names, given by one patient man in the early 1800s, are still the names we use today, and the reason they have lasted is that they are right. They capture something real. They describe not just what the clouds look like, but something about the way they came to be, the conditions that shaped them, the mood of the atmosphere that made them. Howard gave the clouds language, and ever since we have been able to say more precisely what we mean when we look up. But long before Howard, and long after him, the clouds needed no names to be beautiful. They did not need to be understood to be comforting. A child lying in the grass in the middle of a summer afternoon, watching a cloud slowly change shape. That child is not thinking about condensation nuclei or adiabatic cooling. They are simply watching, simply resting in the presence of something that moves slowly and means no harm and takes up space in the sky without apology. And that simple act, looking up, following the slow drift of a cloud from one side of your field of vision to the other, does something to the nervous system, something quieting, something that signals deep in the body that there is no hurry, that the world is large and mostly peaceful, that whatever was pressing so heavily on the mind a moment ago is not, in the vast and unhurried context of clouds, particularly urgent after all. This is what a cloud is. Not cotton, not smoke, not solid, not fixed. It is water in its most patient form. It is the atmosphere made briefly visible. It is a gathering of countless tiny droplets, each too small to see, together creating something we look at with a kind of wordless gratitude. It is a thing that floats without effort, changes without disappearing, drifts without going anywhere in particular. It is light enough to rest in the sky for hours without tiring. It asks nothing of the world below it. It only drifts, only continues, only hangs in the air between the sun and the ground and makes the light a little softer, the world a little quieter, the afternoon a little easier to be still inside of. And tonight, that is more than enough. Every cloud begins its life far below. Not in the sky, not in the cold upper reaches of the atmosphere where the air thins and the blue deepens toward something that is almost not blue at all. Not in the place where we eventually see it drifting, slow and pale and unhurried. A cloud begins its life at the surface of things, at the edge between water and air, in that thin and quiet boundary where one world ends and another begins. It begins on the surface of the ocean, where waves rise and fall and the water stretches so far in every direction that the horizon becomes a kind of fiction, a line the eye draws because it needs to stop somewhere. It begins on the surface of a quiet lake at dawn, when the water is so still it looks like dark glass and the trees on the far shore are reflected so perfectly that you could almost believe the world had been folded in half. It begins on the surface of a slow river, moving without hurry through a valley it has been carving for thousands of years, patient in a way that makes human patience seem brief and fragile. It begins on a dewy morning field, where each blade of grass holds a single drop of water at its tip like a small, cold jewel, and the whole meadow glitters faintly in the first low light of the day. These are the birthplaces of clouds. Not dramatic. Places, not places where anything appears to be happening. Just surfaces, just the quiet, ordinary boundaries between water and sky. And yet, from these still and gentle places, something begins to move. The sun rises. Or if the sun has already been up for hours, it continues its slow arc across the sky and its light continues to fall, warm, patient, utterly consistent, on everything below. The light reaches the surface of the water and the water absorbs it, not all of it. Some bounces back, which is why the ocean glitters, why a lake in afternoon light looks as though it is made of something metallic and alive. But much of the sun's energy goes directly into the water and the water accepts it and the water warms. This warming is not dramatic. It does not happen all at once. It is a slow process, the kind of process that you could sit beside for an hour and not notice with any single sense, not see, not hear, not smell. It is the kind of change that only becomes visible in its results, in what it eventually causes, in the long, slow chain of consequence that begins with warmth and ends, eventually, with a cloud drifting across an afternoon sky thousands of feet, above the place where the warming began. As the surface of the water warms, the molecules of water nearest the surface begin to move faster. This is what warmth is, at the level of molecules, motion. Energy expressed as movement, as vibration, as a kind of restlessness that builds the more heat is added. And at the outside, surface of the water, where the liquid meets the open air, some of these faster-moving molecules reach a speed that allows them to do something remarkable. They escape. They break free of the surface tension that holds the body of water together, that keeps each molecule connected to its neighbors in the liquid state, and they launch themselves into the air above. They become vapor. They become gas. They leave behind the cool, still world of the liquid and enter the open, moving, invisible world of the atmosphere. This is evaporation. And it is one of the most quietly important processes on the surface of this planet. The word evaporation sounds like something clinical, something that belongs in a chemistry classroom, written on a whiteboard beside an equation. But the reality of it is anything but clinical. Evaporation is the ocean breathing. It is the lake releasing itself into the sky. It is the river giving a part of itself to the air so that the air can carry it somewhere new, somewhere it has never been, and deposit it as rain on a hillside or a forest or a field that has been waiting for weeks in the dry heat of summer. Evaporation is the mechanism by which water travels. It is the beginning of every journey water takes through the atmosphere. Every raindrop that has ever fallen began as evaporation. Every snowflake, every morning fog, every cloud that has ever crossed the face of the sun, all of it began at a surface with a molecule of water moving just fast enough to let go. And it happens constantly. This is perhaps the most astonishing thing about evaporation. Not that it happens, but that it never stops. Right now, in the darkness on the other side of the world where it is already tomorrow, the ocean is evaporating. In the noon heat, where the sun is directly overhead and the water is warm and restless, it is evaporating faster. On the rivers, on the lakes, on every wet surface anywhere on the planet, the water is rising. It is always rising. The atmosphere is never empty. Of this process, the sky is always being fed, always being filled with invisible water climbing upward from the surfaces below, carried by the warmth of the sun and the movement of the wind into the open space of the air. The water vapor that evaporates from the surface is invisible. This is important, and it is worth sitting with for a moment. We associate water with something we can see. We can see it in a glass. We can see it falling from the sky. We can see the wet patch it leaves on stone when a wave retreats from the shore. But water vapor is perfectly transparent. It has no color. It bends light almost exactly the way dry air does. If you were standing at the surface of the ocean and watching the evaporation happening directly in front of you, you would see nothing. The water would simply be there, flat, reflective, ordinary, and the vapor would be rising from it invisibly, silently, continuously, and you would have no way of knowing. The air above the water would look the same as any other air. Clear. Open, apparently empty. But it is not empty. It is full of water that has forgotten how to be liquid, at least for now. Full of water in its most free and wandering form. Unattached, uncontained, moving wherever the air moves, rising when the air rises, spreading through the atmosphere the way a secret spreads through a room, invisibly, inevitably, reaching further than you might expect. This invisible water is carried upward by the wind and by the simple physics of warm air. Warm air is lighter than cool air. The molecules in warm air are moving faster and are spread further apart, which makes a given volume of warm air weigh less than the same volume of cooler air around it. And lighter things, in a world governed by gravity, rise. So the warm air near the surface of the water, warmed by contact with the sun-heated water below, begins to lift, and it takes the water vapor with it. The vapor doesn't need to do anything. It doesn't need to push or strive. It simply rises with the air that surrounds it, carried upward the way a leaf is carried upward in a column of warm air rising from a sun-baked road on a summer afternoon, effortlessly, without intention, simply following the physics of warmth and lightness and rise. As the vapor rises, it moves through the lower layers of the atmosphere, the troposphere, the layer in which almost all weather happens, The layer in which clouds form and winds blow, and the temperature changes with altitude in ways that shape everything about the weather we experience at the surface. The troposphere is not uniform. It has currents and pockets and regions of different temperature and humidity. It is, in its own invisible way, as varied and complex as the surface of the ocean, full of movement and pattern, full of places where air is rising and places where it is sinking, full of the slow and enormous circulation of warmth and moisture that keeps the planet's climate in the delicate balance that has made life possible here for billions of years. The water vapor travels through all of this invisibly. It mingles with the other gases in the atmosphere, the nitrogen and oxygen and argon and carbon dioxide that make up the bulk of the air we breathe. It moves in the currents. It drifts. It spreads. And it carries within it, waiting to be released, the potential for everything that comes next. The potential for clouds, for rain, for snow, for the soft gray light of an overcast morning. All of that potential is invisible, traveling in the air, waiting for the conditions that will allow it to finally appear. There is something almost tender about the idea that the air around you right now is full of water you cannot see. That, as you breathe in the air of the room you are breathing in water vapor. A small amount but real, measurable, present. That if you could somehow slow time down enough and watch a single molecule of water vapor floating in the air of the room, you could trace it backward, back through the air, back through the window, back through the atmosphere, back to a surface somewhere, maybe an ocean thousands of miles away, maybe a river in a country you have never visited, maybe a rainstorm that passed through your own town last week, soaked into the ground and slowly released back into the air over the days that followed. The water in the air around you has a history you will never fully know. It has been somewhere. It has been many somewheres. It is passing through this room, through this moment, on a journey that will continue long after tonight. The sky is always full of this invisible water. On very humid days, the kind of heavy, warm days in summer when the air feels thick and the body feels slow and it seems like the world itself is reluctant to move. The amount of water vapor in the atmosphere is high. The air is saturated, or nearly so, which means it is holding nearly as much water vapor as it is capable of holding at that temperature. And on dry, clear winter days, when the air feels sharp and cold and the inside of the nose prickles with each breath, the air holds much less vapor, but it still holds some. There is almost always water in the air. The atmosphere is almost never completely dry. The process of evaporation is too constant, too widespread, too fundamental to ever truly stop, and all of this invisible water is waiting. Every molecule of vapor drifting in the atmosphere above you right now is waiting, in its quiet and unknowing way, for the conditions that will transform it, that will cool it, that will give it something to cling to, that will allow it to return to its liquid form and join with millions of other droplets and become something visible, something that catches the light and casts a shadow and drifts across the face of the sun on a slow afternoon. Every molecule of vapor in the sky is a cloud, in waiting, a cloud in its earliest, most invisible, most patient form. This is how it all begins. Not with drama, not with effort, with warmth and a surface, and the quiet willingness of water to let go of itself and rise. The sun falls on the water warms, the molecules at the surface begin to move a little faster, reach a little further, and then release, quietly, invisibly, one molecule at a time, into the open air above. And the air receives them, and the wind carries them, and they rise, and drift, and travel through the atmosphere on a journey that began at the edge of the water and will end, eventually, in the sky. The cloud is coming. It does not know yet that it is coming, but it is. It has already begun. It began the moment the sun touched the water, and the water, warmed and restless, let a little of itself go. As water vapor drifts upward, it enters a different world. Not a dramatic world. Not a world that announces itself with any particular sound or light or sensation. Just a world that is, in the most gradual and patient way imaginable, cooler. A world where the temperature drops a little with every foot of altitude, where the air thins almost imperceptibly with every 100 feet climbed, where the familiar warmth of the surface, the warmth of sun-heated ground and sun-warmed water, and the low, dense air that holds the day's heat close to the earth long after the sun has moved on, begins to fade. The vapor rises into this cooler world the way you might walk slowly from a warm room into a hallway that is just slightly less warm, and then into another room that is slightly less warm again, each transition so gentle that you almost don't notice until you realize at some point that you are cold, that the warmth is behind you now, that the air around you has changed. This is the atmosphere. This is the slow gradient that governs everything that happens in the sky above us. Near the ground, the air is warm and dense and full. It sits close to the surface of the earth, pressed down by the weight of all the air above it, thick with moisture and the heat that the earth absorbs from the sun each day and releases slowly back into the air through the night. This lowest layer of the atmosphere is the layer we live in, the layer we breathe, the layer that feels familiar to our bodies because our bodies evolved inside it and have known nothing else. It is the layer where weather happens, where the wind moves through the trees and the rain falls and the fog gathers in the low places in the early morning. It is a layer full of life and movement and the constant exchange of heat and moisture. Between the earth and the sky and above it, the air cools. This is not a complicated fact, but it is a profound one. For every 1,000 feet of altitude gained, the temperature of the surrounding air drops by roughly 3 to 5 degrees Fahrenheit, depending on the moisture content of the air and the conditions of the atmosphere on any given day. This rate of cooling has a name, the lapse rate, and it is one of the fundamental rhythms of the atmosphere, as reliable and as constant as the turning of the earth. The air at 10,000 feet is substantially colder than the air at the surface below it. The air at 20,000 feet is colder still, and the air at the heights where the highest clouds form, the thin, wispy cirrus clouds that float near the top of the troposphere, is cold enough to freeze water instantly, cold enough that the clouds themselves are not made of liquid droplets at all, but of ice crystals so fine and so light that they seem less like water and more like the idea of water drawn in pale brushstrokes across the blue. Into this cooling world, the water vapor rises. It carries with it the warmth it borrowed from the surface, the energy the sun put into the water, the energy that allowed the molecules to move fast enough to evaporate in the first place. But as it rises, as it moves higher into the atmosphere, it begins to lose that warmth. The air around it is cooler, and the vapor rising through that cooler air begins to cool as well. Slowly, gradually. The way everything cools when surrounded by something colder. Not all at once, but gently, steadily, degree by degree, and as the vapor cools, something begins to change. The molecules of water vapor, which have been moving quickly and freely through the air, bouncing off other molecules, spreading out, filling whatever space is available to them the way all gases do, begin to slow down, not dramatically, not visibly, but at the molecular level, the energy that kept them moving fast enough to remain a gas begins to diminish. The molecules slow. They lose the frantic, free-moving quality of warm gas and begin to move in a way that is more hesitant, more searching, more willing to connect. They begin to look, in the most molecular sense possible, for something to hold on to. This is the beginning of condensation. It is the reversal of evaporation, not water leaving its liquid form and becoming gas, but gas losing enough energy that it is ready, willing, even eager to become liquid again. The process has a threshold. There is a specific temperature, different for different amounts of water vapor in the air, different on different days in different parts of the atmosphere, at which the vapor is ready to condense. This temperature is called the dew point. And when the rising, cooling air reaches the dew point, when the temperature of the air drops to the level at which the water vapor can no longer remain a gas, condensation begins. But here is the thing. Here is the part that turns a simple physics lesson into something that feels almost like a story, almost like the atmosphere has a kind of hidden life to it that operates just beneath the level of what we can see. The water vapor, ready to condense, ready to become liquid, cannot simply do so on its own. It cannot condense out of nothing onto nothing. Water vapor in perfectly clean, perfectly particle-free air would need to be cooled far below the dew point before it could condense. A state called supersaturation that rarely occurs in the natural atmosphere because the natural atmosphere is almost never clean or particle-free. In the real sky, above the real earth, the air is full of things. Tiny things. Nearly weightless things. Things so small that they float in the atmosphere almost indefinitely, carried by the faintest currents, drifting for days and weeks and sometimes months before they fall back to the surface or are washed out of the air by rain. Dust. This is the word we reach for first, because it is the most familiar. Dust is everywhere. It rises from dry fields when the wind moves across them, lifted from the surface by the same physics that lift water vapor. The movement of air. Over a surface, the energy of wind translated into the energy of lifted particles. It rises from deserts and travels astonishing distances. Dust from the Sahara regularly crosses the Atlantic Ocean and lands in the Amazon rainforest, carrying minerals from the ancient dried lake beds of North Africa to the nutrient-hungry soils of South America. Dust from the Gobi Desert in Central Asia reaches the western coast of North America. Dust is a traveler. Dust is always in the air, always drifting, always present in the atmosphere in quantities we cannot see but can sometimes feel. In the dryness on the skin, in the faint haze that sits over a city on a still day, in the reddened sunsets that follow a dust storm somewhere upwind, and sea salt. Every time a wave breaks on the ocean's surface, every time the wind tears the top off a whitecap and sends it skittering across the water in a brief, fizzing line of foam, tiny particles of sea salt are launched into the air. They are so small, far smaller than anything we would recognize as a grain of salt, that they do not fall back immediately. They rise with the warm air above the ocean's surface and enter the atmosphere and drift. They travel inland on the prevailing winds. They move through the lower atmosphere in their billions and trillions, these tiny particles of salt from the sea, and they are some of the most effective condensation nuclei in the atmosphere. Because salt is hygroscopic, it attracts water. It has a natural affinity for moisture. A particle of sea salt floating in humid air will begin to collect water vapor around it even before the air has fully reached the dew point. Salt reaches for water. Salt welcomes water. Salt is, in a sense, always ready for a cloud and pollen. The air in spring and early summer is full of it, the reproductive material of trees and grasses and flowers, released in enormous quantities because reproduction is, for a plant, the most important thing, and the best strategy for success is abundance. Release enough pollen into the air and some of it will find its way to where it needs to go, but much of it drifts far beyond its intended destination, floating in the atmosphere for days, becoming part of the invisible cloud of particles that fills the air above the surface of the earth at any given moment. Pollen particles are larger than dust particles and sea salt particles, large enough that they fall out of the air more quickly. But while they are aloft, they too can serve. As condensation nuclei, they too can become the anchor around which a droplet of water gathers, and there are others. Smoke particles from fires, both the natural wildfires that have always burned through forests and grasslands and the combustion products of human industry that have been added to the atmosphere in increasing quantities over the past 2 centuries. Particles of volcanic ash launched into the stratosphere by eruptions and carried around the world by the high-altitude winds. Even particles of meteor dust, the tiny fragments of space rock that burn up as they enter the atmosphere, leaving behind microscopic traces of their passage that drift down through the layers of air and eventually become part of the atmosphere's supply of condensation nuclei. The sky is full of the remnants of things, full of the traces of fire and ocean and desert and space, and all of this invisible, various, well-traveled material, is ready to serve as the foundation for a droplet of water. When the cooling water vapor finally meets one of these particles, something happens that is so small it is far beyond the reach of any unaided human sense, and yet so important that without it, the sky would be a very different place. The water vapor molecule encounters the surface of the particle, and instead of bouncing away, as it might in warmer air with more energy, it stays. It settles against the surface of the particle and gives up a little of its remaining energy and becomes, in that moment, liquid. It becomes a droplet, impossibly small. A sphere of water wrapped around a grain of dust or a crystal of salt or a fragment of pollen, held together by the surface tension of water pulling it into itself, keeping it round and whole and present. And then another molecule of vapor arrives, and another. They find the surface of the growing droplet and they too condense, adding their infinitesimal volume to the droplet, making it very, very slightly larger. The droplet grows. Slowly, patiently, molecule by molecule, it accumulates. It is still far too small to see. It is still one of those droplets that would fit 100 across the width of a single human hair. But it is real now. It is liquid. Now, it is, in the most technical and precise sense of the word, a cloud droplet. And where there is one, there are soon others, because the same cooling air that caused this droplet to form is also cooling other regions of the atmosphere nearby, and other particles are gathering their own water, and other droplets are forming, and the process that began with one invisible molecule. Finding one invisible particle of dust is multiplying across an enormous volume of sky. This is where a cloud begins, not at the moment it becomes visible from the ground, not at the moment it is large enough to cast a shadow, not at the moment someone looks up and says, "Look, a cloud is forming." It begins here, in the invisible, in the meeting of a slowed molecule of water vapor and a drifting particle of dust in the cooling air above the surface of the earth. It begins in a place and at a scale we will never see with our own eyes. It begins in the kind of quiet that is not the absence of activity, but the presence of activity too small and too gentle for our senses to register. It begins the way most important things begin, not with a dramatic moment, but with a threshold crossed so quietly that there is no sound, no signal, no announcement. Just a change. Just water finding something to hold on to and holding on. And slowly, in the cooling air, the droplets multiply. They gather. They drift together in the slow currents of the rising air column, each one tiny, each one weightless, each one a small completed miracle of physics and patience. And together in their millions and billions they begin to be something, they begin to be visible, they begin to be a cloud, still forming, still growing, still in the process of becoming what it will be. But present now, real now, caught. In the light, reflecting the sun back toward the earth in that particular soft white glow that means water is up there, suspended, resting in the air. The invisible has become visible. The vapor has become a cloud. And somewhere far below, on the surface of the ocean or the shore of a quiet lake, more water is evaporating, more vapor is rising, more of the invisible journey is beginning, feeding the cloud, sustaining it, keeping it present in the sky for as long as the conditions that made it continue to hold. The dust did that. The tiny, weightless, well-traveled, ancient and ordinary dust did that. It gave the water something to hold on to, and the water, grateful in the way that water is always grateful for a surface, wrapped itself around the dust and became something new. Something we look up at. Something we watch drift slowly across the afternoon sky and feel, without quite knowing why, a little more at peace. Not all clouds are the same. This is one of those facts that seems obvious the moment it is said, and yet when you really sit with it, when you let it open up into everything it contains, it becomes something much larger and much more interesting than a simple observation about the sky. Not all clouds are the same. The sky is not just filled with one kind of thing, repeated endlessly in slightly different sizes. The sky is filled with genuinely different forms, different textures, different personalities almost, each one produced by a different set of conditions, each one the visible record of a different kind of movement happening in the atmosphere at the moment it formed. Every cloud you have ever looked at was shaped by something. Every cloud is a consequence. Every cloud is, if you know how to read, it. A story written in water and light across the face of the sky, and the sky has a gentle language for telling these shapes apart. It is not a complicated language. It does not require years of study or special instruments or any particular technical knowledge to begin to understand. It requires only the willingness to look up and to look carefully and to notice that what is up there is not all the same, that some clouds are round and some are flat, that some sit low and heavy near the horizon and some are so high they look like they belong to a different sky entirely, that some are bright white and clearly defined at their edges and some are gray and soft and blurred, fading into the surrounding air without any clear boundary. The language of clouds is written in shape and altitude and texture and color, and once you begin to learn even a few of its words, the sky becomes a different place. It becomes a place that is saying something, always saying something quietly, in the particular form that water takes when it meets the air at a certain temperature moving in a certain way. Begin with the clouds that most of us drew as children, the ones that appeared on every crayon drawing of a house or a family or a sunny day, those rounded, bumpy white shapes floating in a blue sky, stacked softly on top of themselves like something baked rather than something formed from vapor and physics. These are cumulus clouds. The name comes from the Latin word for heap, for pile, for an accumulation of things placed one upon another, and the name is exactly right. Cumulus clouds are heaps. They are piles. They are clouds that have been built upward rather than spread outward. Clouds that have grown vertically rather than horizontally. Clouds that have reached toward altitude instead of spreading across it. They form when warm air rises quickly, when the sun heats the ground unevenly, which it always does because the ground is never perfectly uniform, because a dark plowed field absorbs more heat than a pale sandy beach, because a paved road heats faster than the grass beside it, because the surface of the earth is a patchwork of different materials with different relationships to sunlight. Some patches of ground become warmer than others, and the air above these warmer patches becomes warmer than the air around it, and warm air rises. It rises in a column, a thermal, an invisible upward current of air that carries warmth and moisture from the surface of the earth into the sky, above. If you have ever watched a hawk or a vulture circling slowly overhead without moving its wings, rising higher with each slow circle without any apparent effort, you have watched a bird using a thermal, riding that invisible column of rising warm air the way a leaf rides an updraft, getting something for nothing, gaining altitude through the simple gift of warm air moving upward. The water vapor in that rising thermal rises with it, and as it rises, it cools, and eventually, at a very specific altitude that meteorologists can calculate based on the temperature and humidity of the surface air, it cools enough to reach the dew point. Condensation begins, droplets form, and a cloud appears, seemingly from nowhere, at a very precise height above the ground. This is why the bases of cumulus clouds on any given day tend to be at almost exactly the same altitude. Look at a sky scattered with cumulus clouds on a summer afternoon and notice how their flat bottoms all seem to sit at the same level, as if they have all been placed on the same invisible shelf. That shelf is the altitude at which the rising air on that particular day with that particular temperature and humidity reaches its dew point. Below that level, the sky is clear. Above it, clouds begin. The atmosphere has drawn a line, invisible but precise, and the clouds sit exactly on it. Above their flat bases, cumulus clouds rise. The warm air keeps pushing upward and the cloud keeps building, piling new droplets on top of older ones, growing taller and more elaborate. A young cumulus cloud on a calm summer morning might be modest, a small, rounded puff, bright white, sharply defined, sitting placidly in the blue sky like a quiet thought. It rises slowly. Its edges are crisp because the air around it is drier and slightly cooler, and the boundary between cloud and not cloud is well defined. Over the course of the morning, if the heating of the surface continues, if the thermals keep rising, the cloud builds. The top rises. New towers appear within the existing form, pushing upward. The cloud becomes more complex, more three-dimensional, a landscape of rounded forms layered on top of one another, each one soft and distinct, and lit from above by the sun. There is something endlessly watchable about a developing cumulus cloud. If you have ever lain in a field on a summer afternoon, truly lain down, flat on your back, looking straight up, and watched a cumulus cloud for 20 or 30 uninterrupted minutes, you will know what it is to watch something that is always moving and yet never seems to hurry. The cloud changes constantly. New towers rise at the top. Old ones at the edges soften and dissolve as the drier surrounding air mixes in and evaporates the droplets. The shape shifts in ways that are never abrupt, never sharp, always gradual, always smooth, always at the pace of something very large moving through something very still. Watching a cumulus cloud for long enough produces a particular quality of calm that is hard to find anywhere else. The mind, given something slow and large and beautiful to follow, tends to quiet. The thoughts that were pressing and insistent a few minutes before begin to feel less urgent. The body, lying flat in the grass with the whole sky above it, begins to understand in some wordless way that it is small, and that the world is large, and that this is not a frightening thing but a restful one. And then there are the stratus clouds. Where cumulus clouds rise, stratus clouds spread. Where cumulus clouds build upward into towers and heaps and layered vertical structures, stratus clouds move outward in every horizontal direction, thin and even and gray, covering the sky the way a blanket covers a bed, not dramatically, not with any single gesture, but steadily, until the coverage is complete and the sky above is no longer blue but a uniform, soft, featureless gray. Stratus clouds are the clouds of still overcast days. They are the clouds that make the light flat and diffuse and gentle. They are the clouds that turn the morning soft and quiet and make the world feel muffled and close and somehow easier to be inside of. They form differently from cumulus clouds. Instead of a sharp, powerful updraft pushing warm air quickly upward, stratus clouds form when air rises slowly and gradually across a very wide, flat area. When a warm air mass moves across a cooler surface, a warm front sliding slowly over cold ground, or warm humid air drifting over a cold ocean current. It is lifted gently, broadly, without the focused energy of a thermal. The rising is so gradual that there is no concentrated column, no single point of ascent. Instead, the air lifts across a vast horizontal expanse, all of it cooling at the same slow rate, all of it reaching the dew point at roughly the same time, all of it beginning to condense into cloud at the same altitude simultaneously. The result is not a heap or a tower, but a layer. A sheet of cloud that stretches from horizon to horizon, low and even and continuous with no dramatic peaks and no flat-bottomed towers. Just a gray, quiet, unbroken roof of cloud that closes the sky and makes the world below it feel contained and hushed. There is a kind of beauty in stratus clouds that takes longer to appreciate than the obvious beauty of cumulus clouds. Cumulus. Clouds are beautiful in a way that is easy and immediate. They are picturesque, photogenic, the clouds of greeting cards and children's drawings. But stratus clouds require a different kind of attention. Their beauty is not in their form, which is deliberately formless, but in the quality of light they create. Under a stratus sky, the light is not directional. It has no source. It does not throw shadows. It comes from everywhere at once, soft and even, and it falls on the world below with a kind of democratic gentleness, illuminating everything, equally flattening the contrasts, turning the world into something that looks almost like a very gentle painting. The colors under a stratus sky are muted but rich. The green of wet grass under a gray sky has a depth and saturation that the same grass in full sun does not. The gray of a stone wall under overcast light is full of subtle variation, not just gray but 100 quiet grays, lavender and blue and brown and almost green. Stratus clouds make the world look like it is waiting for something, and there is something restful about waiting. Something that asks the body and the mind to be still, to be patient, to simply be present in the soft and even light. And then, above all of it, the cirrus clouds. The highest of all, the thinnest of all. The ones that feel least like what we think of when we think of clouds and most like something else. Like the sky has been lightly marked with a pale pen, or combed through with a fine-toothed comb, or written on in a language of curves and wisps and trailing threads that means something we have not quite learned to translate. Cirrus clouds form so high in the atmosphere, typically above 20,000 feet, sometimes much higher, that the temperature at their altitude is far below freezing. Liquid water cannot exist there. Any water that reaches those heights freezes before it can form a droplet, so cirrus clouds are not made of water droplets at all. They are made of ice crystals, tiny, hexagonal, geometrically perfect crystals of frozen water, each one a small miracle of molecular arrangement, each one catching the light in a slightly different way depending on its orientation and its size. Because they are made of ice crystals rather than liquid droplets, cirrus clouds look different from any other cloud in the sky. They are thin, translucent almost. The blue of the sky shows through them, slightly muted, slightly hazed, like blue seen through the thinnest possible layer of frosted glass. They have no clean edges. They fade at their margins into nothing, trailing off into wisps and threads that seem to dissolve as you try to follow them with your eye. They move differently too. The winds at high altitude are faster than the winds near the surface, and cirrus clouds are often stretched and streaked by these high-altitude winds into long, sweeping curves that arc across the sky in forms that look more intentional than anything the atmosphere ought to be capable of. They look painted. They look like someone with a very fine brush and a very light touch has moved it across the blue and left these pale, trailing marks behind. Each cloud shape is a map of how the air has been moving. This is what makes learning to look at clouds something more than just an appreciation of beauty, though it is certainly that too. Every cloud in the sky is a record of temperature and humidity and the direction and speed of air movement in the atmosphere at the moment the cloud formed. The rounded heaps of cumulus say, here the ground was warm, and the air rose quickly and the sky built upward. The flat sheets of stratus say, here, a large mass of air lifted slowly and cooled broadly, and the sky covered itself quietly and evenly. The thin, swept lines of cirrus say, here, at a great height, the wind has been moving fast, and the water is frozen and the sky has been combed into these delicate, pale, trailing forms. The sky is always telling a story. It is telling it in the only language it has, the language of water and air and temperature and light. And the story it tells is always about what has been happening in the atmosphere, invisibly, in the hours and days before we looked up. Clouds are the visible record of the invisible. They are the moments when the air, which is always in motion, always changing, always doing something we cannot see, makes itself briefly legible, briefly readable, briefly present to our senses, in a form we can follow and rest in and feel something about. And the feeling, for most people, is not complicated. It is not the feeling of solving a problem or understanding a mechanism. It is something simpler and older and more restful than that. It is the feeling of looking up at something very large and very slow and very beautiful and realizing, quietly, that it has been here all along, that the sky has always been doing this, that the clouds have always been forming and drifting and dissolving and forming again, long before there were eyes to watch them, and that they will keep doing it long after tonight, which is, in its own, quiet way, one of the most restful thoughts in the world. A cloud in full sunlight is white. This is one of those facts that most of us have simply accepted since childhood, without ever really stopping to ask why. The way we accept that the sky is blue, or that shadows are cool, or that the sun is brightest at noon. Clouds are white. Of course they are. They have always been white. We drew them white as children. We describe them as white when we are trying to tell someone about a beautiful day. White clouds, blue sky, warm sun. This is the shorthand we reach for when we want to say that everything was right with the world on a particular afternoon. But the whiteness of a cloud is not a simple thing. It is not the whiteness of paper or the whiteness of paint or the whiteness of snow, though snow and clouds share more than we might initially think. The whiteness of a cloud is something more interesting than any of those. It is the whiteness that happens when light meets water in just the right way, at just the right scale, and something almost magical occurs in the space between the two. To understand why a cloud is white, it helps to understand what light actually is. Sunlight, the light that travels 93 million miles from the surface of the sun to reach the upper atmosphere of the Earth in just over 8 minutes, is not a single thing. It looks to our eyes like it is simply bright and colorless, or perhaps very slightly golden on a clear day. But that appearance is a kind of compression. Sunlight is actually a mixture of every color of visible light simultaneously: red, orange, yellow, green, blue, indigo, violet, and every gradation between them. All of these colors, all of these wavelengths of electromagnetic radiation are traveling together in the beam of sunlight, mixed so thoroughly that they appear to our eyes as a single unified brightness. We only see them separated when something, in the environment, does the work of separating them. When light passes through a glass prism or through a raindrop, and each wavelength is bent by a slightly different amount, and the colors fan out into a spectrum. This is what a rainbow is. It is sunlight being separated by water into its component colors. each wavelength going its own way, spread across the sky in the particular arc that the geometry of light and water creates. But in a cloud, the opposite happens. In a cloud, the light is not separated. It is scattered, bounced, deflected, redirected, but scattered equally across all its wavelengths. Each tiny water droplet in the cloud acts like a very small, imperfect mirror, not a flat mirror that reflects light in a single direction, but a rounded one that scatters light in many directions at once. And because the droplets in a cloud are large enough, much larger than the molecules of gas that make up ordinary air, they scatter all wavelengths of visible light with roughly equal efficiency. Red light and blue light and green light and yellow light all bounce off the surface of a cloud droplet in approximately the same way, deflected in the same range of directions, scattered with the same readiness. None of the colors is favored. None is scattered more than another. All of them are redirected together, in the same proportion in which they arrived, bouncing through the cloud and eventually emerging from its surface in a mixture that is still, as it was when it entered, the complete spectrum of visible light. And the complete spectrum of visible light when it reaches the human eye all at once is perceived as white. This is what white is, at its most fundamental. Not the absence of color, not a blank, not a nothing, but the presence of all colors together, mixed so evenly that the eye cannot distinguish any single one, and instead reads the combination as brightness without hue. White is every color at once. And a cloud is white because it scatters every color at once, because it treats red and blue and green with the same indifference, the same willingness to deflect, the same complete lack of preference. The cloud does not absorb the light. It does not take any of it for itself. It simply redirects it, bounces it, passes it back toward the sky and toward the eyes below with all its colors intact. And what arrives at the eye is white. Brilliant, clean, the particular white of a cloud. On a clear day that makes you squint a little even when you're not looking directly at the sun. This is why clouds seem to glow. On a clear day with the sun at the right angle, a large cumulus cloud does not merely look white. It looks luminous, as if it has a light source inside it, as if it is generating brightness rather than merely reflecting it. This effect is especially striking at the edges of a cloud where the sunlight enters at an angle, and the scattering sends light in all directions through the outer layers of the cloud, illuminating them from within. The edges of a sunlit cumulus cloud on a summer afternoon have a brightness and a warmth to them that is almost hard to look at directly, not because they are as bright as the sun, but because they are bright in a way that seems alive, that seems to come from inside the cloud rather than from outside it. This is all physics, all scattering, all the consequence of water droplets the right size doing what water droplets the right size do when sunlight passes through them. But knowing that it is physics does not make it any less beautiful. If anything, it makes it more so, because the beauty is not accidental, not arbitrary, but the precise and inevitable result of water and light interacting according to rules that have been in place since long before there were eyes to register the brightness. Now consider what happens as the cloud grows, as it deepens, as the updraft that created it continues to push warm, moist air upward through its base, adding more and more droplets to its interior, making it thicker and denser and taller. In a young, thin cumulus cloud, the modest, cheerful puff of a calm summer morning, sunlight enters from above and passes through the relatively shallow depth of the cloud and exits from the bottom with most of its energy still intact. The cloud is thick enough to scatter the light and appear white from outside, but thin enough that significant amounts of light still make it through to the base and beyond. The bottom of the cloud is lit from within. It appears white, or perhaps a very light gray, almost the same color as the top and sides. Light reaches all of it. The cloud seems uniformly bright. But as the cloud grows, as more water is added, as the droplets multiply, as the depth of the cloud increases from a few hundred feet to a few thousand, the situation changes. Each layer of droplets within, the cloud scatters the light that passes through it. A little bit of the light bounces backward. A little bit bounces sideways. With each additional layer of droplets the light must traverse, a little more of it is deflected, a little more is lost from the downward moving beam. By the time the light has traveled through a very deep cloud, through thousands of feet of densely packed water droplets, each layer stealing a small percentage of the remaining brightness, there is very little of it left to illuminate the base of the cloud from above. The deep interior of a thick cloud is a dim place. Not dark the way a closed room at night is dark, but shadowed, gray, the light reduced to a fraction of what it was when it entered at the top. And so the bottom of the cloud falls into shadow, its own shadow. The cloud casts a shadow on itself, the way a very thick piece of frosted glass casts a shadow on the surface beneath it, not because the glass is dark, not because it is absorbing the light, but simply because it is thick enough that by the time the light has passed all the way through, there is not much of it remaining. The bottom of the thick cloud seen from the ground below is gray. The gray is not a different color applied from outside. The gray is simply the absence of the white that would be there if the cloud were thinner. It is the gray of depth, the gray of accumulation, the gray of a cloud that has been quietly growing for hours, gathering water from the air around it, building itself upward and inward and becoming, slowly and without any hurry, something much larger and much heavier than it was when it began. This gray, the gray of the underside of a thick cloud, is one of the most evocative colors in the natural world. It is a color with a feeling attached to it. Most people, looking up at a gray sky, feel something shift in them, something that is not quite unease but is related to it, something that is an ancient and entirely reasonable response to the atmosphere signaling that rain may be coming, that the open sunny conditions that have prevailed are about to change, that the sky is preparing to do something. This feeling is not irrational. It is the result of millions of years of evolution in creatures that lived outdoors, that needed to read the sky the way we now read screens, that understood the gray of clouds as information about what the next few hours would bring. The gray cloud feeling is not anxiety. It is attentiveness. It is the body noticing something that the mind has not yet consciously registered. It is a very old kind of intelligence, reading the sky in the way the sky was always meant to be read, and the sky is indeed telling something. A gray cloud, a deeply gray cloud, one whose base is a uniform, flat, dark gray, is a cloud that has grown very large and very full. It is a cloud that has been doing what clouds do for a long time, accumulating water vapor, converting it to droplets, building itself up layer by layer until it has reached a depth and a density that the light can barely penetrate. A gray cloud is not a different kind of cloud. It is the same cloud it always was, made of the same water droplets, formed by the same process of evaporation and condensation, and the slow work of dust particles in the cooling air. It is simply more of itself, fuller, heavier, in the sense that it contains more water, more potential, more of what clouds are made of and what clouds are capable of becoming. A gray cloud is a cloud that has been quietly growing, quietly gathering. It has been building itself in the sky while the world below went about its business, while people walked to work and children played in schoolyards and traffic moved through intersections and the ordinary business of the day continued. The cloud has been doing its own slow work overhead, invisible in its interior processes, its deepening and darkening only gradually becoming noticeable to the eyes below. And as it has grown, as it has darkened, it has been preparing. Not in any intentional sense. The cloud has no intention, no awareness, no understanding of what it is becoming. But the physics of what it is doing lead inevitably toward a particular outcome. A cloud that grows large enough and full enough will eventually produce rain. The droplets inside it will eventually collide and merge and grow heavy enough to fall. The cloud will at some point let something go. There is something deeply restful about this idea if you let yourself settle into it. The gray cloud is not ominous. It is not threatening. It is simply a cloud that has done its work thoroughly. A cloud that has gathered everything it can gather and is now full, complete, ready. The gray color is the color of readiness, the color of a thing that has accumulated quietly over a long time and is about to release what it has been holding. Rain from a gray cloud is not a failure of the cloud or a loss. It is the cloud completing itself, returning its water to the surface from which it came, continuing the cycle that the sun began when it first touched the water and the water first began to rise. The gray cloud and the rain that follows it are the same story, just the next chapter. The same water that evaporated from the ocean and rose invisibly into the atmosphere and found a dust particle to condense around and became a droplet and became part of a cloud is now returning. Gray was just the color it wore while it was waiting. And after the rain, the cloud will be smaller, lighter, perhaps white again at its edges where the droplets are fewer and the light can pass through freely. Perhaps dissolving altogether, releasing the last of its water and dispersing into the air as vapor once more, invisible again, ready to begin the journey over. The sky will clear. The blue will return. And somewhere far below, the water that fell as rain will be warming slowly in the sun, preparing to rise again, carrying with it the invisible potential of the next cloud, the next gray, the next slow, and peaceful accumulation of water in the cooling air. The cloud was white. Then it grew, and it was gray. Then it rained, and it was white again. And the sky, as always, continues. Patient, unhurried, always doing something, and always, in the end, at peace. A cloud can hold its water for a long time. This is one of the things about clouds that we do not often think about, that the water suspended in the sky above us is in no particular hurry to come down. It drifts. It waits. It continues to exist in its suspended, floating form for hours, sometimes for days, carried by the wind across distances that can span entire continents, all the while holding its water in those tiny, weightless droplets that are too small to fall, too light to be pulled meaningfully downward by gravity, too perfectly scaled to the gentle upward push of the air beneath the cloud to do anything other than simply remain where they are. A cloud is, in a very real sense, water that has learned to be patient. Water that has given up its rushing and its flowing and its falling at least for a while, and has agreed to simply float, to simply be still, to simply exist in the sky above the world and drift with the wind and change shape slowly and cast its moving shadow across the fields and rooftops below without any urgency, without any destination, without any particular intention about what comes next. But eventually, something changes. Eventually, the balance that has been holding the cloud's water in suspension begins to shift. The droplets, which have been floating so contentedly in the slow upward currents of air within the cloud, begin to grow. This growth is not sudden. It is not the result of any single dramatic event. It is the result of the same patient accumulation that formed the cloud in the first place. The same slow gathering, the same quiet addition of one small thing to another small thing, repeated so many times that the result becomes something qualitatively different from what it was at the beginning. The droplets grow because clouds are not still places, even when they appear still from the ground. Inside a cloud, the air is moving constantly, rising in some places, sinking slightly in others, circulating in slow, invisible currents that carry the droplets through different regions of the cloud, past other droplets, through areas of slightly different temperature and humidity. And as the droplets move through the cloud, they encounter each other. When two droplets meet, when the slow circulation of air within the cloud brings one droplet close enough to another that they touch, they merge. This is coalescence, the process by which small droplets become larger ones, and it is one of the fundamental mechanisms by which rain is made. The merged droplet is now slightly larger than either of the two droplets that formed it. And a larger droplet moves differently through the air than a smaller one. It falls a little faster under gravity. It sweeps through a slightly larger volume of air as it moves. It encounters other droplets more frequently, and when it encounters them, it merges with them too, growing larger still, falling a little, faster still, sweeping through more air, collecting more droplets, growing heavier with each collision and each merger, each new addition making the next addition more likely, each increase in size making the droplet more effective at gathering still more water from the cloud around it. This process, this slow snowball of accumulation, this patient gathering of one droplet onto another, takes time. It does not happen in an instant. A cloud droplet begins at roughly 1/100th the width of a human hair, as we have already understood, and a raindrop, the finished product, the droplet that has grown large enough and heavy enough to fall from the cloud and reach the ground, is roughly 2 millimeters in diameter. That is a difference in size so large that it is almost difficult to express as a simple comparison. A raindrop contains roughly 1 million times the volume of a single cloud droplet. To make one raindrop, the cloud must gather approximately 1 million of its tiny suspended droplets together into a single falling drop. 1 million small mergers, 1 million collisions and coalescences, 1 million tiny additions of water to water, each one invisible, each one silent, each one happening deep inside the cloud where no eye can follow it. 1 million times. 2. Small things become one slightly larger thing, until the slightly larger thing has become something large enough to fall. This takes time. And the cloud holds its water patiently through all of it, through all the collisions and mergers, through all the slow growth of droplets that are still too small to fall, through all the invisible internal circulation that keeps the growing droplets suspended even as they become heavier. The cloud waits. Not consciously, not with any awareness of what it is waiting for, but in the way that all physical processes wait, by simply continuing to be what they are, until the conditions change enough that something new becomes possible. The cloud is still a cloud, the water is still water, and the accumulation continues quietly, one droplet at a time, until somewhere inside the gray depth of the cloud a droplet grows large enough that the air can no longer hold it. There is a threshold. There is a size at which a droplet becomes too heavy for the upward currents of air within the cloud to keep it suspended. Below that size, the droplet floats. The gentle push of rising air within the cloud is enough to counteract gravity, to keep the droplet where it is, to maintain the balance that makes the cloud a cloud rather than rain. But above that size, gravity wins. Not dramatically, not with any sudden lurch or visible transition, but quietly, inevitably, the larger droplet begins to fall. It moves downward through the cloud, through the layers of smaller droplets still, suspended in the air below, collecting some of them as it falls, growing slightly larger still, falling slightly faster. It begins its descent, and then it falls out of the base of the cloud and into the open air below. This is the moment of rain, not the moment it reaches the ground, that comes later, but this moment, the moment when the droplet crosses the boundary between cloud and sky and begins the long fall through clear air toward the surface of the earth below. It is a droplet of liquid water, now clearly visible if you could see something so small falling through air that is warmer and drier than the inside of the cloud. And as it falls, a new set of forces acts on it. The air through which it falls pushes back against it, not enough to stop it, not enough even to slow it significantly at first, but enough to shape it. The falling droplet is not the perfect sphere we might imagine. The air resistance pressing against its bottom flattens it slightly as it falls, giving it a shape that is less like the teardrop of cartoons and more like a tiny hamburger bun, rounded on top where the surface tension of water pulls it into a curve, flattened on the bottom where the air pushes up against it. This shape shifts as the droplet falls faster, as the air resistance increases, as the balance between gravity pulling it down and air pushing up against it shifts and changes through the long descent. The droplet falls slowly at first, in the thick, dense air just below the cloud base. The resistance is relatively high and the droplet is still small, and its terminal velocity, the speed at which the downward pull of gravity is exactly balanced by the upward push of air resistance. The speed at which it falls at a constant rate without accelerating further is modest. A small raindrop falls at perhaps 2 or 3 miles per hour. A larger one falls faster. The largest raindrops, the fat, heavy drops of a summer thunderstorm, drops that you can hear when they hit a leaf or a window, fall at 15 or 20 miles per hour. But even the fastest raindrop is falling slowly by most standards. Slowly enough that a child can run through rain. Slowly enough that a spider's web can hold the drops that collect on it without collapsing. Slowly enough that the fall from cloud base to ground, a distance that might be several thousand feet, takes many seconds. The raindrop falls slowly through the air, and the air it falls through is not perfectly still. The wind moves it sideways. The turbulence of the lower atmosphere buffets it gently, and the path it takes from cloud to ground is not a straight vertical line, but a long, slow curve, blown by the wind, drifting as it falls, arriving at the ground some distance downwind from the point directly below where it left the cloud. Some raindrops never make it. In dry climates, in places where the air between the cloud base and the ground is very dry and very warm, a raindrop can begin to evaporate as it falls, can begin to return to vapor before it reaches the surface. The water it took the cloud so long to gather begins to dissipate back into the dry air below. Sometimes this evaporation is complete. The raindrop disappears entirely before it reaches the ground, leaving behind a curtain of falling rain, visible from a distance beneath a cloud but stopping short of the earth. A phenomenon called virga. From far away, virga looks like the cloud is trailing dark, wispy curtains beneath it, the rain that almost was, the water that rose and gathered and fell, but did not quite complete its journey. It returned to the air instead, invisibly, to try again somewhere else at some later time when the conditions below the cloud are more welcoming. But most raindrops do complete the journey. Most of them fall all the way through the warm air below the cloud and arrive at the surface of the earth. And the moment of arrival is one of the smallest and most perfect moments in the natural world. A raindrop landing on a still pond sends up a tiny crown of water, a ring of smaller droplets ejected by the impact, rising briefly and then falling back into the surface. The pond rings outward from the point of impact in slow, perfect circles, each one expanding steadily until it fades at the edges into the general ripple of the rain-covered water. A raindrop landing on a dry stone makes a small dark circle that fades at the edges. A raindrop landing on a leaf sends a tiny shiver through the leaf, and if the leaf is at the right angle, the drop rolls slowly toward the edge and hangs there for a moment before falling to the leaf below. A raindrop landing on a rooftop is part of the sound we call rain. That soft, continuous percussion of water on tile or slate or shingle that is one of the most reliably soothing sounds in the human experience. People have been falling asleep to the sound of rain on rooftops for as long as there have been rooftops to fall asleep under. The water is home. That is the simplest way to say it. The water that evaporated from the ocean, or the lake, or the river, or the dewy morning field. The water that rose invisibly into the atmosphere, that drifted for hours or days through the lower sky, that found a particle of dust to condense around and became a droplet and joined with millions of other droplets and became part of a cloud. That water is home. It has completed the arc of its journey through the atmosphere and returned to the surface. Not necessarily to the same surface it left. The water that evaporates from the Pacific Ocean might fall as rain on the slopes of a mountain range 1,000 miles inland. The water that rises from a river in one country might fall as snow on a glacier in another. The atmosphere is a transport system as well as a storage system, and the rain that falls in any given place is the accumulated water of many different surfaces, gathered from many different origins, brought together in a single cloud, and delivered to a single location by the particular path the wind took on a particular day. And the moment the water lands, the cycle begins again. This is the thing about water. It never truly stops. It arrives at the surface and immediately begins to be acted on by the forces that will send it back into the sky. The sun, which set the whole process in motion in the first place, falls on the puddles and ponds and wet streets and rain-soaked fields and begins to warm them. The water absorbs the warmth. The molecules at the surface begin to move faster, and some of them, the fastest, the most energetic, the ones that happen to be at the surface at the right moment, escape. They evaporate. They enter the air above as invisible vapor, carried upward by the warmth, beginning the slow climb through the atmosphere that will end, eventually, in another cloud, another gray sky, another patient accumulation of droplets, around another grain of dust drifting in the cooling air. The water that just fell as rain is already, in the very moment of its falling, beginning to return. Some of it evaporates immediately from the warm surfaces it lands on. Some of it soaks into the soil and is drawn up through the roots of plants and released through their leaves in a process called transpiration, a quieter, slower form of evaporation, the forest breathing its water back into the sky. Some of it flows into rivers and makes its way back to the ocean, where the sun will warm it again, and the cycle will continue. There is no end point in the water cycle. There is no place where the water stops and declares itself finished. It is always moving, always transitioning between states, always in the process of becoming something other than what it currently is. Ice to liquid to vapor to droplet to rain to river to ocean to vapor again, endlessly, in a cycle that has been running without interruption since water first appeared on the surface of this planet billions of years ago. And this is the deepest comfort in the story of clouds, if you are willing to receive it. The water in the cloud above you tonight has been here before. It has been rain before, and river before, and ocean before, and vapor before, and cloud before. It has fallen on landscapes that no longer exist. It has been part of storms that no one alive today witnessed. It has been ice in glaciers that have long since melted, and it has been the morning dew on fields that were plowed up and built over centuries ago. It is ancient water, carrying no memory of any of it, asking no questions about where it has been or where it is going, simply continuing, simply moving through its cycle with the same patient indifference it has always had. The cloud that drifts above you tonight is made of the same water that has always been here, the same water that has always been rising and falling and rising again in the same endless, unhurried, deeply peaceful repetition. The cloud drifts, the rain falls, the water rises, the cloud forms again, slowly, quietly, always returning, always beginning, always in its patient and unhurried way, at rest. And so, perhaps, can you be. So tonight, as you drift toward sleep, imagine yourself far above, weightless, floating among those tiny droplets of water, held up by nothing but warm, slow-rising air. You are light. You are still. You are drifting. The clouds have been forming and dissolving above us since long before there were eyes to watch them. And they will keep drifting long after tonight. There's something deeply restful about that. The sky is always at work, quietly, slowly, without any hurry at all. If Sleepy Science helps you rest, subscribe so the next journey is always close by. Sleep well. The clouds are watching over you.